Hey folks, I hope you're ready to stretch your muscles as we start talking about Lightning Web Components. For those who haven't seen the video about what we are developing here, you'll see the link. And today we will talk about a dynamic component generation, Git Branching Strategy. I also try to share all my thoughts on how I make decisions. I wanna touch on overgeneralization and much more. And of course, let's start by creating a repository. I already created a new rep in GitHub, and this friendly resource provided us with information on how to connect our local rep with a remote one. For this, we create a project and go to the terminal. Don't forget to create a local rep using git init, and here we add our remote rep, push our branch with one commit to the GitHub. And as you can see, our branch has been successfully deployed, and the question here is, what's next? At this stage, the whole beauty of this world is revealed to us, because the internet will tell you about the different strategies for organizing your branches. One of the most popular is probably Git flow. It looks something like this. It is strategies that covers practically everything. You have a development branch right here, which you create based on the main branch. Then from this development branch, you create a separate feature branch for your task, such as creating fields and adding to the layout, which you merge with the development branch once you're done. And after some time, you create a branch for your release from the development branch, micro actions synchronize back to the development branch, and all this is accompanied by testing. And as soon as you're convinced that everything works, you merge this release branch under a specific tag to the main branch. There is a lot of steps, branches, conflicts, etc. However, this strategy is more likely what you need if you really have a lot of people, teams, and you're working on something grand. But the truth is, the fewer branches you have, the better. Your primary goal is not to choose a strategy that covers everything, but to choose a strategy that covers what you actually need. For this reason, let's think from the basics, and this basic is called feature branching. It is fairly simple strategy. You have a main branch that contains the most relevant and with high hopes working code, and for each separate task you create a feature branch. Work on it, stick to the idea that this branch is only for one specific task. Create a pull request to the main branch, get approval, CI/CD, etc. and merge. That's it. The previously mentioned Git flow strategy is actually based on this strategy, with additional ideas for releases and hotfixes. But as I said, keep it simple. That's why we will move forward with the feature branching strategy, creating feature branches, working on them, and merging with the main branch. Now let's move on to the actual application. The first task is to create two components, two steps for the review process. Object, where admin specifies which as object and which records should be reviewed, and he also specifies the fields that should be checked with additional instructions for each of them. Later, these records and these fields will be distributed between reviewers for the actual work. What I originally thought was to create two separate components which I'll separately place on the layout and which will exchange data with each other. Since in Salesforce we work with the component-based architecture, we don't create one component that has everything, right? We create separate modular components. But in this case, I ultimately decided to place these two separate components in the parent component, since there is a certain set of operations that the two components will have to perform in the exactly same way, and in general, they have a common task, and I try to reduce the amount of duplicate code and improve the readability of what is really happening here. Visually, it looks like this. We have a parent component that dynamically generates component based on which step we are at right now. Here we have two steps, selecting the type of records and filtering, and the second one is selecting the fields to review, and the parent component is responsible for dynamically generating these components depending on which step we are at. I don't use the simple LWC if conditions, meaning if I go back to the code, here you can see that I use the LWC component, which allows us to dynamically generate a component depending on this constructor right here. A good sign whether this approach is really suitable for you or not are parameters. For example, in my cases, both components accept the same parameter, but if the components were categorically different, I probably wouldn't gone this way. In the context of performance, this is also a rather heavy approach. Anyway, let's see what this constructor here is. It's actually the result of importing a specific component, meaning the standard approach would be like this. We use the import function and specify our component with a namespace, and after that we assign the result to the variable, which is passed to the LWC if attribute in the markup and results in the generation of the component we need. We can also change this component to any other by importing another component using the same syntax, just changing the name of the component. And the last thing to remember is that in the metadata we need to add a capability Lightning dynamic component to make this dynamic generation possible. That's all well and good, but how does it work behind the scenes? The idea is actually quite simple. This LWC component in the markup is just a placeholder that expects right here to receive a promise object that resolves the Lightning element constructor. Meaning, if we look at our JavaScript, scroll up, we will see that our component, or rather the class, extends from the Lightning element class, which means that our component, which we are looking at right now, will always be a sub-component, right? And so the LWC component in the markup expects to receive a component that extends this Lightning element class. That is the standard concept of runtime polymorphism, but now in JavaScript. I will also note that the promise object is not something mystical or incomprehensible. It's just a regular object with a value like any other variable. The key difference is that a promise is used for asynchronous operations. For example, when you import a component to be dynamically generated, the process takes time, no doubt. So instead of waiting, your code keeps running and you get a promise that the value will be available just a bit later. So essentially, a promise acts as a placeholder, again, that eventually resolves with a value or an error. What I did in this case, since the imports have to be specified statically in one way or another, I created an array of the steps that need to be performed to submit the review process, right here. And in each step, I specify the name of the step. I'll show you where I use it in a sec. And here I also have the label, the value, and the import of the specific components that should be loaded depending on which step the user is on right now. And based on this array in the markup, I generate a Lightning progress step component like this. This progress step is clickable in my case, and when user clicks on it on the interface, I use this array to get a corresponding import and use it to load a component. Now the key question of what we see here, did it have to be done this way? Why didn't I just specify these two steps here statically in the markup without using a loop, etc., and then I could just load these imports into the global variables and get rid of this array completely? This is definitely an option, but then implementation will be more difficult for long-term maintenance. You have to consider that as well. For example, to add a new step, I would need to add a new element to the markup, add a new import, and in the determine review progress step function right here, add a new if condition to get this import. Also, if the user clicks on a step 2, how do I determine which component needs to be loaded? So in any case, it comes down to some kind of mapping between the step and the component, which would cause a lot of extra steps and places to manage this. But in this case, everything is quite simple because I combined everything that needs to be combined into one single array. So this is kind of generalization, when we try to make the code easier to maintain and extend by extracting a common structure or behavior to a higher level abstraction. This is a great approach, but what is really important here is to say enough at some point. That is, in this case, even though I have an array and everything looks quite dynamic, right? At a certain stage, I still statically specify the key depending on which field is populated. That is, right here, if the filter criteria is empty, I indicate we are at a step 1, otherwise at a step 2. However, I could theoretically get rid of these static if conditions as well. For example, I could add right here, I could add a new condition key to each step in the array and specify in some special syntax the condition under which this step should be displayed. Something like that. Then add a processing of this condition in the function and define the step and generalize the implementation even more. Why I didn't do that? Let's assume that I actually did. We have this condition key and I define the step dynamically. When I do this, I understand that this condition right here is custom, completely custom. That is, I need to implement the processing, add or conditions, brackets to specify the order of the conditions, and much more. After that, I need to explain how it works, right? Which I'll most likely do by adding a comment here about how it should work, what can, what cannot be specified, and so on. The first problem here is the comment. As you remember from my video about a clean code practices, the comment should explain why and not how. In this case, it is already a clear violation of this practice, which is the first sign. In addition, it increases the amount of code and development time. We simply complicate things with the high hopes that someday it will be useful. This is definitely a bad thing. Such overgeneralization of the code does not lead to better readability or maintainability, but rather the opposite. It has more questions and complications. Think about it.